A source S and a detector D are placed at a distance d apart. A big cardboard is placed at a distance h from the source and the detector as shown in the figure. The source emits a sound wave of wavelength d/2, which is received by the detector after reflection from the cardboard. It is found that the sound waves coming directly from S to D is in phase with the reflected one. So by what minimum distance should the cardboard be shifted away so that the reflected wave become out of phase with the direct wave? Fine. Now first of all, the two waves are in phase. That is the one coming from here directly and the another one is the reflected one. So they are in phase. So first of all, what I'll do is I'll calculate the path difference, and that has to be equal to n lambda. Fine. This distance is d/2 and this distance is given as root 2d. So let this distance is O. Fine. So the value of SO will be equal to under root of d/2 whole square plus root 2d whole square, and part difference will be given by 2 times of SO minus SD. This is the part difference in the initial case, so just substitute the value, that is 2 times of under root of d/2 whole square plus root 2d whole square minus SD, that is d, and that has to be equal to n lambda because the two sound waves are in phase. So lambda is d/2, 2 times of d/4 plus 2d square and square minus d, which comes out to be 2d. So d is d cancelled and comes out to be 4. Fine. Now the question says that by what minimum distance should the cardboard be shifted away so that the reflected wave becomes out of phase with the direct phase. Now if it is moved by a distance x, let's say this distance is x and this is the new point O dash. Fine. So the two reflected wave and the direct wave will be out of phase, but the value of n will be 4, right? So we know that part difference in case of destructive interference is given by 2n plus 1 of lambda. Fine. So in this case the part difference will now become 2 times of SO dash minus SD. So the value of SO dash will be equal to under root of d/2 whole square as usual plus root 2d plus x whole square minus SD, that is the value of d, and substituting the value of n equal to 4 and lambda is equal to d/2, I get 2 times of 4 plus 1 by 2 into d/2. Fine. So it comes out to be 9d/4 is equals to 2 times of under root of d/2 whole square plus root 2d plus x whole square minus d. So on solving this value for x, the value of x comes out to be 0.13 times of d. That is the answer.